State within the component tree. All of your React components can have their own state, but should they? The joy of using React does not come from chasing down state variables all over your application. The joy of using React comes from building scalable applications that are easy to understand. The most important thing that you can do to make your application easy to understand is limit the number of components that use state as much as possible. In many React applications, it is possible to group all state data in the root component. State data can be passed down the component tree via properties, and data can be passed back up the tree to the root via two-way function binding. The result is that all of the state for your entire application exists in one place. This is often referred to as having a single source of truth. Next, we will look at how to architect presentation layers where all of the state is stored in one place, the root component. Color Organizer App Overview. The Color Organizer allows users to add, name, rate, and remove colors in their customized lists. The entire state of the Color Organizer can be represented with a single array. Colors. ID 0175D1F08C641BFXD02DF5734D2984. Title Ocean at Dusk. Color 00C4E2. Rating 5. ID 83C7BA2F73924D7D9E2335 at 1X6046. Title Lawn. Color 26AC56. Rating 3. ID A11E3995B0BD4D5HHC485E49A7F7F23. Title Bright Red. Color FF0000. Rating 0. 5. Dan of Raouf. Presentational and Container Components. Medium, the 23rd of March, 2015. The array tells us that we need to display 3 colors: ocean at dusk, lawn, and bright red. Figure 6 to 8. It gives us the colors hex values and the current rating for each color in the display. It also provides a way to uniquely identify each color. Figure 6 to 8. C. A layer organizer with 3 colors in state. This state data will drive our application. It will be used to construct the UI every time this object changes. W. When users add or remove colors, they will be added to or removed from this array. W. When users rate colors, their ratings will change in the array. Passing properties down the component tree. Earlier in this chapter, we created a star rating component that saved the rating in the state I in the color organizer. The rating is stored in each color object. It makes more sense to treat the star rating as a presentational component 5 and declare it as a stateless functional component. P. Presentational components are only concerned with how things look in the application. They only render DOM elements or other presentational components. All data is sent to these components via properties and passed out of these components via callback functions. In order to make the star rating component purely presentational, we need to remove state. Presentational components only use props. Since we are removing state from this component, when a user changes the rating, the data will be passed out of this component via a callback function. Const star rating equals stars selected equals 0, total stars equals 5, on rate equals F equals star rating. ArrayTotal stars.map, I equals. Selected equals I. onClick equals, onRate here 1 / stars selected. Of total stars. First, stars selected is no longer a state variable, it is a property. Second, a non-rate callback property has been added to this component. Instead of calling setState when the user changes the rating, this component now invokes onRate and sends the rating as an argument. State in reusable components. You may need to create stateful UI components for distribution and reuse across many different applications. It is not absolutely required that you remove every last state variable from compo. Links that are only used for presentation. It is a good rule to follow, but sometimes it may make sense to keep state in a presentation component. Restricting state to a single location, the root component, means that all of the data must be passed down to child components as properties figure 6 to 9. In the color organizer, state consists of an array of colors that is declared in the app component. Those colors are passed down to the color list component as a prop. Class app extends component. Constructor props. Super props. This.state equals. Colors. Render. Const colors equals this.state return. Equals app. / colors equals colors / figure 6 to 9. S. State is passed from the app component to child components as properties. Initially the colors array is empty, so the color list component will display a mis. Sage instead of each color. W. When there are colors in the array, data for each individual color is passed to the color component as properties. Const color list equals colors equals color list. Colors.length equals 0. No colors listed. Add a color. Colors.map color equals. Key equals color.id, color /. Now the color component can display the color's title and hex value and pass the call. Alt rating down to the star rating component as a property. Const color equals title, color, rating equals 0 equals. Class name equals color. Title equals color. Style equals background color. Stars selected equals rating /. The number of stars selected in the star rating comes from each color's rating. All of the state data for every color has been passed down the tree to child components as properties. When there is a change to the data in the root component, React will change the UI as efficiently as possible to reflect the new state. Passing data back up the component tree state in the color organizer can only be updated by calling setState from the app component. If users initiate any changes from the UI, their input will need to be passed back up the component tree to the app component in order to update the state. Figure 6 to 10. This can be accomplished through the use of callback function proper. Ties. Figure 6 to 10. Passing data back up to the root component when there are UI events. In order to add new colors, we need a way to uniquely identify each color. This identifier will be used to locate colors within the state array. We can use the UID library to create absolutely unique IDs. npm install UID save all new colors will be added to the color organizer from the add color form compo. Link that we constructed in refs on page 119. That component has an optional call. Back function property called onNewColor. When the user adds a new color and submits the form, the onNewColor callback function is invoked with the new title and color hex value obtained from the user. Import component from React. Import b4 from UID. Import addColorForm from /addColorForm. Import ColorList from /ColorList. Export class extends component. Constructor props. Superprops. This.state equals colors. This.addColor equals this.addColor.bindThis. addColor title, color. Const colors equals this.state.colors. ID v4, title, color, rating 0. This.setState colors. Render. Const addColor equals this const colors equals this.state return. Equals app. onNewColor equals addColor / colors equals colors / this.setState colors. Remove colorid. Const colors equals this.state.colors.filter. Color equals color.id equals id. This.setState colors. Render. Const addColor, rate color, remove color equals this const colors equals this.state return. Equals app. onNewColor equals addColor / colors equals colors. onRate equals rate color. onRemove equals remove color / both rate color and remove color expect the ID of the color to rate or remove. The ID is captured in the ColorList component and passed as an argument to rate color or remove color. The rate color method finds the color to rate and changes its rating in the state. The remove color method uses array.filter to create a new state array without the removed color. Once setState is called, the UI is re-rendered with the new state data. All data that changes in this app is managed from a single component. App. This approach makes it much easier to understand what data the application uses to create state and how that data will change. React components are quite robust. They provide us with a clean way to manage and validate properties, communicate with child elements, and manage state data from within a component. These features make it possible to construct beautifully scalable presentation layers. We have mentioned many times that state is for data that changes. You can also use state to cache data in your application. For instance, if you had a list of records that the user could search, the records list could be stored in state until they are searched. Reducing state to root components is often recommended. You will encounter this approach in many React applications. Once your application reaches a certain size, two-way data binding and explicitly passing properties can become quite a nuisance. The Flux design pattern and Flux libraries like Redux can be used to manage state and reduce boilerplate in these situations. React is a relatively small library, and thus far we've reviewed much of its functionality. The major features of React components that we have yet to discuss include the component lifecycle and higher order components, which we will cover in the next chapter.